for introducing me. My name is Fawaz Alshehri. I'm a PhD student at University College Dublin. As a BIM, becoming a central coordination between design and their activities is becoming an essential to extend BIM capacity to support thermal comfort analysis. During our work in this paper, we find a few limitations and opportunity of extending IFC to support thermal comfort analysis. So, first of all, in this paper, we deform and exchange requirement models, which is capture all the information required for thermal comfort, and then we deform it in the middle a few definition for thermal comfort simulation or production during design stage. So the presentation layout, I'll go through what is, just to give a brief introduction, what is mean by thermal comfort in buildings. And then I highlighted the issue for thermal comfort and BIM, using BIM for thermal comfort limitation, where is the limitation and opportunity in this task. And then the methodology, the process used, and the quick examples. And then we go through the and last conclusion and future work. So I think all of us agree with the above statement. The building where we spend most of our life and time in indoor environment has a significant impact in our health and well-being and comfort. As you can see in the figure on the left hand, we spend above 80% of our life in indoor environment, either in indoor buildings or in the field. It's from a health perspective, in European, the heat wave caused in 2003 caused the death exceeds 35,000 over European. And in terms of economic and workers, and can have the thermal comfort or the uncomfort environment can have in fact impact on workers. It can be directly or indirectly, like they take sick leave if they're not comfortable, or also they take short breaks or long breaks between work to control their environment. And this consumes about 30 billion each year in UK office. So what's mean by thermal comfort? So the Alshehri defined thermal comfort is the condition of the mind when satisfaction expressed with thermal comfort. And you see the pictures, two guys sitting in the same office, one is too cold, the other one is too hot. So it's independent, different categorized. It depends on the type of the activity, it depends on the clothing installation, depends on metabolism rate. A lot of vibration and parameters can impact and can make it influence in both sides. So in order to understand the thermal comfort, so based on the Richard review, we find that thermal comfort has been categorized, it has been classified into three types or three classification. So the first column is the left hand, so what is steady state model. This model looks particularly to evaluate thermal comfort in control environment, in other words, for ventilation building. And the other one, the adaptive model. So the adaptive model looks to let the people adapt with their indoor environment, and this is mostly used for natural ventilation building. The last column, which is looked into very deep details for the human or the building body within space, and look into the comfort levels for the autonomy of the body. It's very complex model. So in this paper, we focus on the support study model and the adaptive model, which is highlighted within green colors. So the future work will consider the third type of the comfort levels. So the limitation here, so in order to understand or to find, to highlight the problem, so we find that most of at the present thermal comfort evaluated in parallel with the energy model. So that means the assess or the design team using the same model for an energy model to evaluate thermal comfort. That means the input parameters for an energy model is being used for to evaluate thermal comfort. So this is going to be fast, in fact, in the result of the output of the evaluation, as the parameters for thermal comfort is not considered in these models. So you modular use a separate CAD model was not connected or collaborated with the original model, and this is another issue. So we find there are still challenges in implementation and BIM-based sustainability analysis because there is a lack of process model standardization for information exchange between between BIM and between simulation tools. So many recent efforts have been focused, but this effort focus in exchange from information between building geometries and between HVAC system into simulation tools. And one of the known efforts in this area, what has been the activity 1.3 from NX60, they deformed that the exchange requirements consider the building and between the HVAC system using Modelica simulation tools to evaluate the building, the energy models. So the current problem is there is no automatically generation between BIM and between simulation tools, and still in common practice, and the manually re-entering still used in most practices. So this has been missing of important information and destroyed of building element, and time consuming and cost loss, and also can affect it in the result and the output of the simulation result. So the main limitation, the summary of the lecture, we find the main limitation, most of the current work focus on either in building geometry or HVAC system, and there is a lack of semantic information required for thermal comfort, representing the data requirement for thermal comfort. Therefore, the research objective we establish aim to define the BIM exchange requirement model, which is automatically and rapidly and economically construct a complete semantic-rich model can be used to evaluate thermal comfort either for new design building or for retrofitted. So the methodology used here. So this is the structure mechanism we use. So first of all, we use the IDM, which information delivery manual, which is to provide the standardized for the information exchange. And then based on that, we define an exchange requirement model. We use the exchange requirement model as a base to start to create the MVD, which is what's kind of subset of IFC satisfaction specification for exchange scenario, and this scenario for thermal comfort. So on the left hand, you see the BIM platform, which is we have a model of BIM, and this model contains parametric data for the geometry, algebraic or parameters for any data, and general specification. And the IFC in the middle, what is we use IFC transfer view, and we extend IFC transfer, and the exchange requirement in the box, the red box, the bottom box, which is our exchange requirement model based on the thermal comfort models that I show in the area. So the MVD capture all the information and convert it to the simulation tools, which will have specific parametric data needed for thermal comfort performance, specific attribute and parameters, and specific indoor and occupants parameters. So we went through a number of steps. So first of all, define all the exchange requirement needed to build the exchange requirement model. And then we specify the IFC identities that needed to support the thermal comfort, and specify the attribute and the parameters and relationship between identities, and then identify the related properties and relationship between. So it's basically we create a custom properties view from the IFC reference view, and we call it the BTCS, what is building thermal comfort simulation. So the semantic information representation, 3 columns here, the coordination system, and the building geometry, and the semantic information. This is accessed in the IFC tools. And you can see in the IFC space, we focus on IFC, most of our requirement based on IFC space, and the properties related to IFC space. For example, we extend IFC occupant. We call it property set for extend space occupant requirement. And we put like the properties like clothing insulation, multiprism rate, and air temperature, and so on. So these parameters we gathering these parameters from the building thermal comfort model, which I presented earlier. So I show here the example how it works. So the parameters in the top coming from the left model. This is the model which we pick the input parameter for it. And the right columns in the Excel sheet separate these parameters and mapping the process to corresponding parameters for the IFC. And we use the IFC doc to mapping these parameters and see the height box where is the extension of the IFC and the extension for occupants. And we see the red box as well, the parameters adding to IFC, to the existing IFC in order to extend it. So in conclusion, providing thermal comfort, we believe it's the main aim for designing the building to create a working living space comfortable for people. Building thermal comfort simulation require specification details information that needed to be exchanged between process. The output of this work will contribute to data transfer, high level of automation, and as Claudia mentioned the presentation before about data quality, high data quality as well. Less manual work, this will hopefully to achieve minimum reliable result data, again the quality of data, and reduce the labor and the time and complexity. So the future work, further specification to include more building element component, and the proposed MVD will apply in fully scale building. And we noted the difficulty to implement the MVT into a real platform. So we work in development ontology to transfer the MVD into RDF, which is help to implement or to test our MVD. Thank you for listening.
Okay, thank you very much. Yeah. Keeping right on time. Yeah. So we still have some time for questions and comments.